Okay, welcome back, and now we're going to look at the power rule. So theorem number 2. So theorem number 2 says let n be a positive integer if f of x equals a power function, right? So if we have f of x equals x to the nth power, then f prime of x is equal to n times x to the n minus 1 power. Or alternatively, we can express it this way by using Leibniz notation. Okay? So now let's do the proof. Okay, so we're going to use the, we're going to use the difference quotient the same way we did before. Okay, so here's the proof. And so the first thing we do is we're going to take the limit of the function. So again, it's going to be f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Okay? And then this is going to be the limit as h approaches 0, and now we're just going to put it in the form. So this is going to be x plus h to the nth power minus, x to the nth power divided by h. Now, this, we're going to use the binomial expansion. The binomial expansion includes the coefficients, which is going to be a combination of how many different ways we could choose and choose r, okay, as you'll see. Okay, and then of course we have the binomial expansion that we see with the exponents. So now I'm going to expand this out. So this is going to be the limit as h approaches 0. And so this is going to start off with ax to the nth power, which is going to cancel with the x to the nth power at the end. And then we're going to start to get the combinations. Okay, so the combinations is going to be start with plus n, because it'll be, first it's n choose 0. So there's n choose 1, which is n, and then we get x squared h. Oh, hold on. X to the n, this should be n minus 1 to the h. And then this is going to be n choose 2, x to the n minus 2, h squared. Plus, then it's going to be n choose 3, that combination, times x to the n minus 3 h cubed. So you see how the pattern's going now. So I'm just going to expand it. So plus dot 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 plus, and now we're going to basically, this is binomial, meaning it's going to be symmetric. So it's going to start to go all the way back down until we get to n again, right? So this goes down and this goes up. And so the coefficients are called binomial coefficients because it's symmetric about both sides. So anyway, you don't need to know that. But what we're going to end up getting is eventually we're going to get n, and then we're going to get x x times h to the n minus 1, right? And then the last one, right, is we get n choose n, which is 1, and we get x to the 0, which is 1, and we end up with h to the n. Of course, we're going to subtract off x to the n, and of course we have our h on the bottom. Now I'm going to simplify this, so obviously the x to the n is going to cancel out, and then I'm going to factor out an h. So watch what happens here. So we get the limit as h approaches 0. I'm going to factor out an h. So we're going to get n x to the n minus 1 plus n choose 2 x to the n minus 2h plus n choose 3 x to the n minus 3 h squared plus plus n x times h to the yeah, that's right, n minus 2, and then plus h to the n minus 1, all over h. Now this is where it gets really simple. Okay, these cancel. Now what happens as h goes to 0? Well, everything that has an h in it goes away. So this all the way down. The only term that does not have an h in it is the first one. So the limit equals n x to the n minus 1. And we're done. That's it. Have a great day.